Okay, for these problems, we're going to use the one-to-one property to solve log equations. And this is a little bit different than what we did when we were using the definition of logarithm. So let me just do maybe what's sort of an easy problem. So ln x equals ln 7. The solution is x equals 7. Now let's compare this to another property or problem that we had, say ln x equals 2. So do you see this is logarithm equals logarithm, and so what I'm saying is that why it's the one-to-one property is that logarithms are one-to-one function, and if the output of that one-to-one function are equal, if the outputs are equal, then the inputs have to equal. This is different over here because so this is logarithm equals a logarithm. If those two logarithms are equal, the inputs are equal. Here's logarithm equals a number, and then what we do in this situation is we use the definition of logarithm. Okay, so this is just a different problem. So we're focusing on logarithm equals a logarithm. What we did in another video is logarithm equals a number. And the truth is that if you get this one, you can sort of get all of them. There's just more algebra involved for other ones. So let's go ahead and try this out. Let's write ln of 2x plus 3 equals ln of x plus 1. So the solution is that we use the one-to-one property, and the logarithms, sort of disappear or cancel out. They don't cancel out like you divide by logarithm, but actually another way to look at this is you could apply the exponential function to both sides. Apply e to both sides, and e and ln cancel out. And so then first of all, let me just change this problem so it's a better problem. Sorry, I thought I was doing that when I wrote it down in my head, but let's make this ln of x plus 10 equals ln of 2x plus 3. All right, so what we're going to do is subtract x from both sides, and we get x plus 3 equals 10, and then subtract 3 from both sides, and x equals 7. Okay, now why I ended up changing this is because the way I set it up before, it had no solution. Let me do the same problem, but I will keep it as I had it before, and we'll see why there is actually no solution. Okay, so again, what I do is I set the inputs equal to each other. I'll subtract x from both sides, and I subtract 3. And well, it looks pretty good, but it isn't. So, but if you look at putting in x, it gives ln of 2 times negative 2 plus 3, which is ln of negative 4 plus 3, which is ln of negative 1. But the domain of y equals ln x is x greater than 0. So there are no solutions. And it's not just, that you get a negative. It's after you put it in and evaluate. For 2x plus 3, we got negative 1. And that's, of course, a negative number. So you can't have ln of a negative number. So that's That's why these particular ones are a little bit more tricky with logarithm. You have to check your answer once you're done, which isn't the worst thing, but it's just one more step you have to do. Okay, so let's look at some others here. Let's have ln x squared equals ln 2x plus 3, and the solution is that you set the input equal to each other, and this is a quadratic, and so for quadratics you bring everything to one side and set equal to 0, and then you factor. So then you get x equals 3, x equals -1. But if you look at the right-hand side of this equation, ln of 2 times -1 plus 3, oh, actually, maybe this will work. That's good. I had to check it. So there's no problem. If I put -1 over here, so let's just check. And then if I put in -1 and I square it, I get ln 1, and that's equal to 0, so that's good too. So actually I was not really following my own advice. Just because it's negative doesn't mean it's not going to work. It's just that when you put in the negative, it has to evaluate something that's positive, so you have ln of a positive number.